So I'm going to be covering the 3 examples that are going to be on the right-hand side with this, just as a continuation from yesterday's set of notes. So as a clarification with this, there's 3 types of collisions we're dealing with. So the first type is elastic collisions. And how I simplified this for you this year instead of next year, where I'll change the definition. So elastic is when 2 objects hit each other and then bounce off. Inelastic is going to be the ones where 2 objects hit and they stick together. And then explosions, that's the most self-explanatory, just something explodes. It's together and then they come apart. So doing the examples on the right here, often they use pool or car crashes to represent collisions. So here we've got a cue ball that's traveling east, and it hits head-on with an 8 ball traveling west. And then we're told after the collision what the cue ball does, and we want to know what the 8 ball is doing. So what is frequently best to do with this? Fuad, you with me? Okay. So what you want to do for this is typically you're going to draw out what's happening in the diagram. This is going to make you not lose marks for forgetting to put negatives. If you just try and put the equation from the beginning, often you'll miss simple facts like this is moving west. So therefore it needs to be a negative velocity. And that's probably on the quiz what you forgot to put in there, or why your number was a little off. So if I draw this out, so here's our initial situation. Here's my cue ball, it's traveling east. Here's the 8 ball, it's traveling west. So this is what we're told is happening. And we can put some variables in here. We can say this is M1, and here's V1 initial, and I have those values. Okay, M1 is 0.25 kg. My V1 initial is traveling to the east, so this is 4.5 meters per second. And I can also write out the information for the cue ball, or the 8 ball, sorry, which is, we'll call M2. Has the same mass conveniently. And V2 initial, so it's 5 meters per second, but because it's moving west, I need to put it as negative, yeah. It's going really fast.
And there's V1.
Yep, we're going to get there. So this is the diagram of what's happening initially. So notice here, initially it helps to figure out negatives. So in the final position, what do we got? We've got the cue balls traveling west. So V2 final is going to be 2 meters per second. And my 8 ball, it doesn't tell us a direction, but I can guess what direction it's going to be. You think it's to the left or to the right?
Oh, right, yeah.
Okay, sure, let's try right. It really doesn't matter. We'll find out once we put it in the equation. So this one's V1F. My computer's been really slow today. So this one's V1F, and we're looking for what V2F is. So since this is a conservation of momentum question, you're going to get 1 mark anytime you write momentum initial equals momentum final. That's going to be 1 mark out of 4 or 5 marks. So it's a very easy mark for you to get just to start off with that. So V1F and V2F is what we're looking for. So momentum initial equals momentum final. This is the whole idea with conservation of momentum, is this one statement. So it's good. That's why it's worth a mark. And now we write this all out. So momentum initial, I've got both objects have an initial momentum. So M1 V1I plus M2 V2I equals M1 V1F plus M2 F. Just like all the other equations, you'll have this memorized by the end of the unit. So now we plug in numbers. You've got the masses. Conveniently, all the masses are the same, so you could technically cross them out, but it's not a good habit to do that, so I'm not going to do it in this question. Exactly. So then you put in the velocities and you just solve for V2F. Do you need me to put in the numbers, or are you good with that? What's that? Yes. M1 times V1I plus M2 times V2I, so on and so forth. Okay, I'll write in the numbers for this one. So again, this is why I'm saying it's good to draw out your diagram, because in our diagram up top, we forgot to put something. I put it here in the equation, but my mass 1 is moving to the left or west. So I need to put this as -2 when I put it in the equation. If I don't, it's going to mess everything up. So plug this into a calculator. And we get so this is what you would get for your answer. Now, remember I said it doesn't really matter what we assume as direction in the beginning. We're going to base it off what we get and the answer. So in this case, V2F we got as a positive number. So if it's positive, what direction does that indicate? East. It's moving east. You don't need to, does this ask for velocity? Yes. So if you're drawing out the diagrams, notice I already put the direction. So you do not need to put direction in your final answer if you've drawn the diagram. If you did not put the diagram, you would need to put east here. So as long as somewhere in your answer you're showing the direction, you're fine. I'll be able to recognize it from that. Exactly. All right, any questions with this? Are we good? This is going to be posted up anyways. It is, well, the video is going to be posted, yeah. Where are you at? Okay, I'll leave it here. So let's talk about the second one then, while you guys are still writing out the first. So now we've got a bullet that's going to hit a stationary wooden block. If it's embedding itself, it just means it goes in and doesn't come back out. So if it's embedded, it means it sticks inside. So we're told at the end the block and the bullet move together at 8.6 meters per second. We want to know what's the original velocity of the bullet. So as I recommended, we're going to draw this out. So here we go. Here's a bullet. It's going towards a wooden block. Let's call this M1 is the bullet. Notice grams. So I need to put in kilograms divided by 1,000. So 0.035 kilograms. V1 initial, 8.6,
Why do we care about the weight of the block?
because it matters. So that's M1. Let's do the wooden block is M2. It's 5 kilograms. And what's V2 initial?
The bullet takes the block and keeps going.
What's my V2 initial? Yeah. I've got one person who's trying to answer my question.
0.
Yeah, there we go. Second person figured it out. And no one caught the other mistake that I made. So what did I do wrong? No. Just seeing if people are awake. You need to be able to read a question properly. We're solving for V1 initial. Where did the 8.6 come from then? So initially, the bullet's traveling towards the block. The 8.6 is once the bullet has hit the block. So this is our final velocity. Yeah, it only took you a little bit to figure it out. So this is what we're looking for.
Yes, that's what I said. Who said you were going?
Yes, everyone was saying this at the very beginning. I heard it. So that's what we're looking for. We need to also draw this in the final position once my computer catches up. There we go. Didn't we already have this conversation before? About the AC? So, since they are now stuck together, they're going to be flying back. But I'm no longer going to refer to this as M1, M2. I'm going to talk about mass total, and I'm going to talk about V total final. Since they're one object, I can total them together. So mass total, add these together, so I'll get 5.035. That's just M1 plus M2. And V total F is 8.6 meters per second. And it doesn't tell us any direction, so we don't really care about that. Any question with the setup? I think you just like being close to me, that's why. Although I remember in grade 9 a certain individual who just would not leave my side, like the entire class. Who would do that?
Who did that? Who did that? Who are you?
How times change over 2 years. Okay, so again, here's a single mark that you can get at the beginning of any sort of collision question. Momentum initial equals momentum final. And then we need to sift through and figure out what we can write. So the initial momentum, I've got two objects. So M1 V1I plus M2 V2I. But now in the final momentum, I only have a single object. They've hit together and they're sticking together. So I can treat them as one. So I'm writing this as mass total, V total final. Mm-hmm. Yep, it'll matter. Wait till you see what the velocity, how the velocity changes. So conveniently, V2i is 0. So who cares about this part? And then we need to solve for V1i. So I have everything I need. I've got M1, 0.035 times V1i equals mass total, 5.035 times this total. Solve for V1i. What do we get? 5.035 times 8.6 divided by 0.035. 1,237 point something. I have a feeling this number's slightly inaccurate, but I don't remember how fast bullets can travel.
Not 100 meters per second.
4,400 and something kilometers per hour, that seems a bit much. But the math in this is right. I didn't convert that incorrectly, right? No, 35 grams, 0.035, yeah.
And there's no way
Sugar.
I put it. Take a 5 kilogram block and make it move as I said. It's just no, there's no way to go flying.
So you're having a misconception about physics in saying that. So it hits the block and you're saying it just falls over, right?
That's what should happen.
Which is what happens when it does this. So even though it's moving backwards at 8.6 meters per second, that doesn't mean the bullet hits the block and then it just goes like this at 8.6 meters per second. As it hits, it's going to fall, which is exactly what it says. So this is not saying it just flies backwards. It hits and falls. I know.
I know.
There's a reason why some of the videos are really long.
The reason why some of the videos are really interesting.
Debatable.
No, it's not. He is not.
All right, any questions with this?
No question.
What are you planning to do as a career?
Career?
Yep.
No.
You get to argue with kids all the time? That sounds like fun.
Oh.
That's exactly why I picked this profession, so I could argue with students.
I bring it up with my parents. Why?
I don't know if I should take offense to that or not. You have no idea. What's that? Good. All right, one more example. So the last type is explosions. So this is basically the inverse of what we just did. Two objects are going to be stuck together and then they fly apart. So here we've got a firecracker sitting in a pumpkin. Once it explodes, you've got the pumpkin moving in two chunks, which is normally not how pumpkins split apart, but in our case it is. One piece is going to travel to the west, and we want to know what is the mass and the velocity of the other piece. And we're going to ignore the firecracker mass.
The mass is 2.
So let's draw this out. So initially, let's say here's our pumpkin.
Mister, if you got this question on the test, then you go.
Like this. What is my V total initial?
This is why the video is taken.
This has only really been happening today.
Why?
Doesn't like me today.
Because Hassan.
Yes, that's exactly why. It's all Hassan's fault. Okay, so what's my V total initial?
10 meters per second.
No. A firecracker is sitting in a pumpkin. So it's 0. Then here goes our pumpkin chunks. So let's call this M1 is moving west. So that's our 5 kilogram piece. So I want two things. Hi. I want mass 2 and I want V2F. Which one can I solve for first? What's the mass?
2.
Why is it 2?
7 minus 1 is 2.
Easy. So mass 2 is just going to be the total mass minus mass 1. So this is MT minus M1. So 2. That's the easy part. And now we're just going to use conservation momentum to figure out the other part.
Momentum initially equals momentum y.
Yep. Come on.
T.
So in this case, our total initial momentum, this one's the two combined objects. So I'm just going to write it out as this. This is equal to M1V1F plus M2V2F. My initial momentum is 0, since the initial velocity is 0. And then I just solve for V2F. So I have everything else. So 0 equals 5 times negative 10 plus 2 times V2F negative 50, bring it over, positive 50 divided by 225. Again, it's asking for velocity, but in my diagram, I made it very clear the direction that it's moving. So in the final answer, I do not need to put it. If you want to be explicit about it, you can write down east. It doesn't hurt you unless you say it wrong, and it does hurt you. But you're most welcome, Faith. Any questions on this?